Hello, everybody, and welcome to this final session of the Ampere Developer Summit, Making the Change Practice of Platform Migration. I'm Dave Neary. I run our developer relations team here at Ampere. I've the great pleasure of being joined by a couple of industry experts here, Maximilian Wittich from Stackable and Andreas Winter-Lucke from Uber. Now, so far today, we've heard from a variety of different use cases and perspectives. Right? We've seen in the first session with Sean some of the reasons why Ampere Silicon is a particularly good match for cloud-native application developers. And in the sessions by Narain and Victor, we've seen some use cases and case studies of situations where applications are a particularly good match for our hardware architecture. But in this session, we're going to go a little bit deeper. We're going to talk about the actual changes that need to happen in your developer infrastructure to accommodate a new deployment platform. So we're going to get into the weeds. Next slide, please. We're going to talk about some of how the cloud has changed software development over the last 20 years. It has been a pretty dramatic change. We're going to hear from Maximilian Wittich. Maxi works for Stackable, which is an ISV in the data platform space. And Maxi is going to share how an ISV has to change its product development and product testing infrastructure to support a new application architecture, hardware architecture, excuse me. And Andreas is going to share the perspective of, as we heard earlier from Vic Grant, Uber has been deploying stateless applications to Arm64 on OCI on Ampere hardware. And we're going to hear from Andreas about how their build and deployment infrastructure has changed to accommodate this change. And finally, we're going to have some discussion and some questions and answers. So if you do have any questions, please use the Q&A tool in Zoom, or you can hang around for our community networking session a little after, where you can ask your questions directly to our community of experts who are going to be available. So before we hear from our guests, next slide, please. We're going to explore a little bit about how, in the last 20 years, the cloud has changed pretty much everything that we know about the best practices of application development. Now, without getting too loquacious about it, I want to talk about some of the ways in which the cloud has changed software development practices and application architecture. And then we'll hear from Maxi and Andreas about the specific examples of an ISV and a large service provider. Okay, so how has the cloud changed the way that we design and implement applications? Well, if you go back 20 years ago, business applications for the most part were service-oriented architecture, three-tier applications. There were large monolithic applications where you had a large business intelligence layer and a stateful database underneath. And as we've moved to the cloud, as we've moved to this worldwide availability, zero downtime expectation that users have of modern cloud applications, web applications, we've seen a dramatic change in the way that those applications are put together. We can't have single waterfall development processes anymore. We cannot have the situation where applications have a release every 6 months or every 12 months, and then deployments require maintenance windows of multiple hours, potentially multiple days. So we've seen a move away from the monolith and towards microservices. Dozens of services and applications working together to provide an overall user experience. Each of those applications can be evolved independently and deploy new versions independently of the rest of the applications. They communicate over well-defined interfaces or message buses. And each of these applications has their own set of components and dependencies, their own data layer, their own caching, their own business logic. So modern applications include hundreds, thousands, tens of thousands of compute elements, whether they're virtual machines, containers, or functions as a service, running all over the world to ensure that there's zero downtime and zero user impact when you deploy a new version of that application. But with the change in application architecture, on the next slide, we'll see that there has also been a change in how we build those applications. If you're aiming for zero downtime, you need to make sure that every single change that's committed to a release branch has gone through rigorous testing and is ready to deploy into production. So every single commit is its own little new version of the software. So we use continuous integration. As soon as a commit goes into the main branch, that project is built, and it's built on a specific reference deployment platform. And this is the first place where we see a change between x86 and ARM64 as you're adding a new deployment platform. You need to make sure that your software is compiled and built on a platform that will run on the target hardware platform, in this case, Ampere. So we provision an ARM64 build environment, we build our project, and we package it, every single commit on every single supported platform. But building is just the first step. You need to make sure that it works well and that it's not going to impact the end user experience. So we also have multiple test phases where you're provisioning integration tests, performance tests, unit tests, simply just testing the components to make sure that they work as they are. And each time you need to have a consistent test environment that resembles the production environment that it's going to go into. Finally, you have a pre-production deployment. And at each stage, you're provisioning the test environments. Each of your test suites need to be adopted to run on the new deployment platform. You need to make sure that all of these test suites are compatible with ARM64 and Ampere hardware. And finally, you get to the deployment phase. In modern web applications, again, zero downtime is expected, zero user impact is what you're aiming for. So we have a pre-deployment environment, which is an exact copy of the production environment, pre-production environment, which is an exact copy of the production environment. And incrementally, you can transition traffic from the old proven deployment environment into the new pre-production environment and verify that it doesn't impact the user experience. So there are a number of deployment architectures that are in common use. So what we're going to hear from today is from Maxi, an ISV perspective, what's involved in adding a new supported hardware architecture for your product. And from Andreas, a slightly different perspective. But Maxi, welcome. Thank you for joining me today. So before we get into how Stackable has added support for ARM64, can you tell me a little bit about Stackable, the company, your product, and what use cases you're aiming to support?
Sure. Thank you for having me, first of all. Stackable is a European, in particular German, startup which builds a modular data platform up on Kubernetes. So we are open source, and we have a curation of all the good stuff from the Apache world. We have, for example, Kafka and NiFi. We have visualizations with superset, or storage with HDFS, job scheduling with Airflow. And the best part of it is we are cloud agnostic, means we run on Google, we run on Amazon, or we run on your new Ampere service on-prem. All you really need is a cluster and Kubernetes on it. And as of 24.7, our latest release, we are multi-architecture, and all is set and gone. And how we get there, I'm gonna tell you now in the following. So Slack works awesome. So we started off our build process with using build chat because it had a very easy image and very easy Ubuntu image for us because it has the basics we really built on. And later, where we needed like bigger runners and more resources, as we wanted to build all our products from source, we switched to Ubi Cloud because they offer us just larger runner, just more hardware and unlimited concurrency. And this was caused by the European Cyber Resilience Act, as they gonna force us to produce SBOMs and keep our CVEs as low as possible. And I'm quite proud to say that we became quite leading in that field.
And Maxi, this is just to provide a little context. Your software is all housed on GitHub, and you're using GitHub's Actions infrastructure with BuildJet and Ubisoft, right? Is that correct?
That's correct, yeah. Yeah. thank you for pointing that out. Yeah, exactly. We are very sad that GitHub is not yet really offering for public repositories ARM runners, but they are almost there, and we're happy to integrate when they are ready. As multi-architecture builds requires you to have parallel builds, we needed to rework our CI/CD platform to only trigger builds which are really necessary. As you can imagine, you have just twice the workload and you just double your cost for CI/CD. And we were in need to develop and introduce some mechanisms to choose the correct software from our repositories. So choose the correct dependency for the correct architecture. What you can see is a curl command. If you look on the really right-hand side, you can see like the $arg sign, which is just the target arg variable substituted by what we want to choose from to have the correct architecture selected at build time. And to do so, we use target arg, which is the Docker internal variable, worked very good for us. And we need to like handle third-party software as GitSync, example, for Airflow or Proto-C as multi-architecture dependencies. Last but not least, we still have test infrastructure. So to test our capabilities on ARM64, respective Ampere, we decided to have 1 out of 4 complete integration tests on the ARM64 architecture to ensure good or decent coverage and test to. So the last slide, I want to focus on what does the customer has to expect. And we chose customer-facing the Docker manifest mechanism, as it offers the user just a JSON file where both architectures are listed and the respective digest of their images. What is very awesome about that the runtime, like Kubernetes or Docker, is able to choose which architecture it's running from and would like automatically choose which image to pull for which architecture, which is awesome for the user, because if you have an x86 cluster already and you want to like have some new nodes, you can just choose ARM64 nodes and Stackable will just do the rest for you. And it's super easy to just scale up from there. Yeah. And last but not least, I want to show you our CI/CD workflow really quick and really brief. Perfect. When you trigger the build, like imagine you change a Docker file, for example, Airflow, and you want to have a new product of this. So what you do is you trigger a parallel build workflow, which is running on the one side on ARM64 and on the other side on AMD64, both natively, which is important. For both architectures, you build the image, you generate the SBOMs, you sign the image, which is important too, and you push it with the respective ARM64 or AMD64 tag. If both builds succeed, you can create a manifest and sign that too. The manifest is the one I showed you just one slide before. Can I go back? Yes, I can. This is the manifest list, so to say, which is the outcome of the last step here. Yeah, and that's pretty much our whole CI/CD process. Thank you for your attention.
Excellent. So what you end up with is a container which, whatever platform you're pulling it on, it's a meta file that then pulls the right binary container after.
Exactly.
That's awesome. Yeah. Okay, well, Andreas, welcome. Thank you for joining me today as well. So we've just heard from Maxi about the perspective of an ISV. Doing full testing on every commit, making sure that everything works for all of your supported platforms. But obviously that's a release process. An ISV does not release software every day or multiple times a day. The situation with a large-scale service provider like Uber, as we heard earlier from Vikrant, is kind of dramatically different in terms of how your deployment and test and build infrastructure works. So can you talk us a little bit about through some of the changes that you have made as part of this transition to being able to deploy your serverless application, not serverless, stateless applications on Ampere hardware on OCI.
Definitely. And thanks for having me here, Dave.
You are most welcome.
Before I dive into infrastructure, I would like to take an overview of Uber Scale. So Uber consists of 5,000 microservices, where most of these services are built from one of our language-specific monorepos. So we have one for Go, Java, Web, and then a small cohort of services that are built from their own microrepositories. All of these services are deployed in 2 regions across 1 to 7 availability zones, depending on how critical the stateless workload is. And together, all these services takes up 2.7 million CPU cores in total. So let's dive into the changes we have done in order to support ARM-based hardware from Ampere. So the process is divided into these phases, where we have the first phase, which is the repository readiness phase. And that is basically about ensuring that our build tool chain is compatible with ARM. So in our case, our language monorepos rely as Bazel as a build system. So it involves making sure that all its build dependencies exist in a Linux ARM variant. Then some of our microservices do also have C++ dependencies. And in order to compile these, we introduced the 6EC compiler, since it does a very good job for cross-compiling C++ code. After the repository readiness phase, we transition into the host readiness phase, which involve building our own host image and Linux kernel with Uber-specific kernel parameters specific for ARM. And then we also have 15 host agents that takes care of networking, logging, metrics, and so on that must be deployed on every single host in our fleet. After host readiness, we transitioned into build and CI readiness, which involved bootstrapping build kite, which we use as a CI platform for triggering tests and building container images on. And we basically needed to bootstrap it on ARM such that we could build natively on that architecture and run tests natively on that architecture. And after we had the CI platform bootstrapped, we had an effort of making all test and container images and Debian packages compatible with ARM as well. And then we transitioned into the platform readiness phase, which basically involve extending our deployment platform with what we call Ampere placement constraints, such that we can go in and configure a specific environment of a given service to be scheduled onto these hosts. And once that was in place, we could start to schedule the first workloads on our infrastructure and start benchmarking. And when everything looked good, we went on to the migration phase, which we are in at the given point in time. So let's have a look at how our build pipeline for building container images have evolved over time. So initially, we had a single architecture build pipeline that was running on BuildKite and was building container images using a builder called Makiso. Makiso is only capable of building for the architecture that it runs on. So because of that, we had to introduce another container image builder that was capable of cross-building for another architecture. And we basically chose Bazel in this case, since we have a lot of experience with that. And then we migrated all our infrastructure components to be built with Bazel such that we could create an ARM variant of these container images. And that now we were basically in a position where we could bootstrap the infrastructure and the entire build stack natively on to run natively on ARM machines, such that we had a build stack for on ARM and one for x86 where we could run Makisu natively on these. And then we ended up creating this multi-architecture build pipeline, as you see in step 3, where we distribute the container image build process across x86 and ARM. And then we have a final step where we create this multi-architecture container manifest that Maxim introduced before, that combines the images together. So let's have a look at our adoption strategy. So we migrate least critical services first. This is also what we call a tier by tier migration strategy. Then the migration flow for each service is that first we enable CI test to trigger on both architectures. Then we enable multi-architecture container images for the given service under migration. Then we migrate its staging environment and let it soak on the Ampere host for some time. And then we migrate the one production zone in the first region and let that soak additionally for some time. And then we continue to the other region as well. And through this process, we have like a lot of validation going on. So we have multiple levels of testing. So we trigger test for every code change whenever we deploy to staging and whenever we deploy to production as well. And then we have like a extensive monitoring process that compare x86 with these ARM-based hosts to ensure that things looks good. So where are we today? So we have migrated more than 2,000 Go services successfully to Ampere host. And we have 3,000 Go services in total, and we expect to be done with those in a few months. And after that, we will continue the migration with Java services. And I just want to call out that this migration would not have been a success without having the partnership with Ampere, who has been crucial in this adoption process. So thanks a lot for that.
Thank you, Andreas. I have a question. You mentioned your soaking process. Is that like, what exactly does that consist of? Is that real life traffic going through the application, or is it synthetic traffic? Like, how do you do the soaking?
So for staging, it's synthetic traffic usually. So that does not really give much signal. But for production, it's obviously live traffic. Yeah.
Okay.
We do not have a good story around sending shadow traffic to staging. A few services support this, but it's not generally available at Uber yet.
Okay, well, I have a few questions for Maxi and Andreas. If we can go to our Q&A slide. I'd like to remind all of our attendees that if you have questions, please ask them in the Q&A tool, and I will be happy to pass them on. But to get us started, Maxi, can you describe, is there anything that you encountered that was surprising that you would do over if you had a chance to do it again in your edition of ARM64 as a supported platform?
Yeah, indeed. When we started developing ARM64, we thought it would be a good idea to start by the product and then working down to the base image. So do it upside down. And if I would have a chance to do it again, I would start definitely with the base image, fix that first, and then work bottom up to avoid some conflict. That would have been way easier.
Right. And in the process that you encountered, did you entirely use services with GitHub, or did you have some physical hardware that you were able to do some build and test on?
Yeah, fortunately, we got some HPE server. I think it's the LA300, which was powered by Ampere. And we had a steady platform during our whole process to develop our ARM capabilities, where we were able to test on, to play on, and which really accelerated our development at that point in time.
Okay. And Andreas, same question to you. Was there anything that was surprising to you? Was there anything you'd do over differently if you had a chance to go back in time?
Good question. No, not really.
Any memorable performance or testing situations that you encountered?
So we were battling at some point with one of our host agents seeing severe performance issues. But then we started collaborating with you guys, and we actually figured out that it was due to a kernel setting, and that basically solved everything. That was maybe the biggest challenge we had.
Okay, and again, different question, but how would you characterize the changes? Have the changes that you've had to make to your CI/CD infrastructure and your deployment infrastructure, have they been more of the order of mechanical, like it was fairly straightforward what you had to do, or were there things where you had some technical challenges or engineering work that you needed?
So I can tell in our case, after we sort of have established the whole multi-architecture build pipeline, and we started to building Go services, we of course faced issues, but they were actually relatively easy to fix. And I think in a matter of a few weeks, we had actually built like all 3,000 Go services, except from a small tail of 100 services that are failing due to various things. We have still not put in an effort of fixing these because their core footprint is not interesting enough in order compared to like the amount of work that would require to fix them.
Okay.
So we have basically postponed that. And for us, the reason why we are migrating to ARM-based hardware from Ampere is because there is an interesting price performance for us.
So I have a question in the Q&A tool to both of you. What have you achieved by adding this new architecture to your deployment platform? Obviously, there is some cost involved in doing that, Andreas, from your perspective, and Maxi, from yours as well. What has the benefit been? What has the outcomes been of this process? Maxi, do you want to start?
Yeah. Well, we don't have customers yet who are actually directly on ARM64 in particular. But what was really freedom for us was that now with the new MacBooks, our software is running on local machines too. And all our developers who are on those particular MacBooks can now develop freely without remote clusters and stuff. So that's the first gain we had at that point, and supporting our community, of course.
Okay. And Andreas, how about you? How would you say how would you quantify the success of this initiative for Uber?
So there are two reasons for us. Of course, the price performance, as I mentioned before, but also the flexibility is super important for us. For instance, if we go back in time during the pandemic, we were actually in a situation where we couldn't get new hardware due to the ongoing hardware shortage. So by being able to run on more diverse hardware, we actually put ourselves in a better situation. So that is also one of our goals.
Okay. Well, thank you both for joining me. That's all the time we have for questions today. I'd now like to invite Pete Baker, who opened this summit several hours ago. I'd like to invite him to join me on screen and close us out. Pete, take it away.
Hey, thanks, Dave. Appreciate it. And really thanks to you and really all our speakers today. Just generously sharing your experience and expertise on the why, the what, and the how of software running in these mixed architecture environments. And also, as a reminder, we've got a whole bunch of channels to communicate. We invite you to join in any or all of these, including our developer community, our YouTube channels, sign up for the developer newsletter, etc. And with that, I'll say thank you, and we'll see you next time.